Pac-Man is a 2D arcade game that has been enjoyed by millions of people for over 4 decades. It's a video game that has stood the test of time, had countless remakes and spin-offs, and today I'll be teaching you how to make a 3D Pac-Man-like video game from scratch. There will be a few key differences, but you can customize the project however you'd like. The project will also be made modular and easily editable, so it can be adjusted on the fly, make custom maps and colors without going into the blueprints. First things first, a free download of the full project will be in the description box down below, and in case you're new to the channel, I am Jovan D, and I help beginner video game developers on their journey in creating games in Unreal Engine 4, so be sure to have Unreal Engine 4 installed from the Epic Games website and launch up a third-person template project. We're using the third-person template project because it already comes with axis mappings and action mappings, but also has a character blueprint with some basic movement logic. The first thing you'll see when you launch up a classic arcade game is the main game menu. We're going to be making this first. Create a new empty level, call it main menu, and open it up. This empty level will be the first level that opens when our player begins the game. We'll be lazy and use the level blueprint to tell the game when it begins play, create a widget, add it to the viewport, show mouse cursor on screen, and set our input mode to UI only from the player controller. That way the player can't move around in 3D space in this level. We're going to make a slightly easier way to set our input mode later on, so don't worry about how sloppy this is right now. Next, we'll create an actor that will control our background music for each level. But before we can choose which sound we're going to play, we need to import some WAV files, which can also be downloaded in the description box down below. These were downloaded from freesound.org. Big thank you to them. So let's drag all of these sound files, which includes background music, pickup collected sound, power pickup sound, hero death sound, menu select sound, and the jump sound, which is everything we'll need. Really quickly make a sound cue out of the background music and set it to looping. We'll create a simple actor blueprint called music controls. For event begin play in this actor, play sound 2D with the background music sound cue that we just made. Create two float variables, one for the volume and one for pitch, both with a default value of 1. Plug them into play sound 2D and make them instance editable. Place that actor anywhere in the level. Let's alter pitch and volume so it doesn't match the background music in later levels. Now we just need to make a quick widget to specify which one is created when the level begins play. Make a folder called Widgets, create a new UI widget blueprint called Widget Main Menu, and open it up. We'll need some text, a button, and some text on the button. Align center the first text and make it look nice with an awesome name. The button should have its brush color changed, and the text should be hit test invisible, and make it a nice color too. Select the button, and on event clicked, we'll need to open a level. Set our input mode to game only and hide our mouse cursor. And for fun, let's play our menu select sound as well. The level we'll open is level 0, which we haven't created yet, but that'll be next on our list. Back in our level blueprint, specify the widget to be created is the widget we just made, widget main menu, and we have ourselves a main menu level with looping music and a button that starts the first level. Speaking of which, create a new level called level 0. This is going to be the longest part in making this game, as it does take up a majority of the video. Once we have level 0 completed, we'll have everything we need to make as many other levels as we want with varying sizes and difficulties. First, we'll need some geometry for the level. With Pac-Man, the levels are made up basically of modular pixel chunks, and we're going to be making our game in basically the same way, so you can easily adjust our levels in the editor. And we'll make those chunks with an actor, which will be our basic geometry in the level. Create an actor blueprint and call it master actor and open it up. We'll want all of our actors to have their colors change easily, so this is what we'll set up in the master actor. All other actors like the level geometry and pickups will be children of this actor. We need to add a static mesh component. At this point, don't worry about what the static mesh is set up to in the master actor. Hop directly into the construction script. Grab the static mesh, create a dynamic material instance, and set vector parameter value to a linear color variable called color with a default value of black. And we'll need to make this variable instance editable. Set the parameter name to base color, and now we need to make a material that has a vector parameter called base color. In the content browser, make a material called mbase for material base. Right-click for vector parameter, set the name to base color, and plug it directly into the emissive input. Make an instance of the material called mibase so we know this is the instance, and now we can start making our level geometry. So we'll make a child of the master actor, call it base geometry, open it up, and we'll need one variable of the type boolean, and we'll name it isFloor, and make it instance editable. Open up the construction script and make a branch with the isFloor variable. For the true path, get the static mesh and set static mesh to shape plane and plug into the parent script. If it's false, get the static mesh and set static mesh to 1 meter cube. Add world offset to 50 in the Z for the cube so it's level and plug into the parent script. When we add this actor to the world now, we can change its shape, but not its color yet. We need to go into the 1 meter cube static mesh and shape plane and set their materials to the MI base that we made earlier. Add a sky sphere so you can see what you're doing and the geometry is clearly working as intended. However, I don't like how it looks in the details panel. I prefer a drop-down menu instead of a simple true or false value. So let's create an enumeration, put it in a folder, and call this enumeration geometry type. Add 2 enumerators, the first one called floor, the second one called wall. Go to our base geometry actor blueprint, add a variable of the type geometry type, and call it type of geometry. Make it instance editable, remove our branch, get the type of geometry variable that we just made, and let's make a switch from it. Plug it in like normal. Now you can see how much more visually pleasing this is in the details panel, and if you add more enumerations, it will just add to the list so we're not stuck with just the 2 options like a boolean would force us to be. Now we're ready to make the level. Place one geometry actor at coordinates 0, 0, 0 and change your grid snapping to 100. I'll clean up the world outliner a bit as well with some folders. Hold Alt and duplicate your selection so it lines up with the first actor. Continue this until you have an entire line of actors. Change them all to pure blue walls. Now we can select them all and start making a grid. I'll simply make a 15 by 15 grid to start. Select whichever actors you want and change them to floor, make them black, and we have ourselves a basic level. We're still missing a few key ingredients though. Pac-Man also has a player character, enemies, and a few different kinds of pickups. Let's start with the player character. We'll make a master character that has the same exact method of changing colors as the geometry actor that we just made. Change the name of our third person character to master character, and this will be our master character. Change the camera boom distance to something closer like 160. Add one static mesh component set to a material sphere. Set the scale to 0.5 in X, Y, and Z to shrink all of our characters. Set material to MI base. Parent the sphere to the capsule component, zero out its position, parent the camera boom to the static mesh, add the color changing logic to the static mesh component that we just added to this blueprint, reset the skeletal mesh component, change the capsule component size to 26 and 26 respectively, set the gravity scale to 2.0 for some more realistic jumping, and that's all we need to do right now. But we'll hop onto the event graph, and we'll keep all the movement logic normal except for jump. For jump, we'll play a sound 2D. The sound will be jump sound, and we'll check to see if we're falling and only play the sound if we're not falling. Otherwise, you can just spam the jump sound by hitting spacebar. All of our characters will have the ability to die, so we'll create a custom event called character death, and we'll create a quick event to change our character's color. Set up a timeline with 1/4 of a second in length with an auto interpolation change from 0 to 1 over that time frame. Set our vector parameter value to a linear color lerp between our current color and an input called color to change, so we can choose the output color whenever we call the event. Lastly, make 2 Boolean variables, both set to true. The first one's going to be called is character alive. The second one's going to be called can character die. So we can change the character's behavior based on those variables. And that's it for our master character. Let's make our player character. Create a child of the master character, and let's call it base player character. Open it up, and we'll create an integer variable to keep track of how many pickups we've collected. Call it picked up amount with a default value of 0. Create another integer variable called total pickups so we can later set it to the amount of total pickups in the level. It doesn't matter what the default value is for total pickups, but we'll just leave it at 0. We'll also need a name variable called next level, which we'll use to set what the next level is. Set the next level variable to instance editable and set the default value to level 0. That's basically all we can do for now since we need some pickups before we can go any further with our player character. So let's create a child of master actor and get to work on a pickup. Let's call this child base pickup. We'll set the static mesh to a cube with the MI base material so that we can change the color. And let's change the scale to something tiny like 0.215 and make it a pure white color. Next, we'll quickly make another enumeration called pickup type, like we did for our geometry, but this time for our pickup type. Add two enumerators, the first one called dot pickup, the second being power pickup. In the base pickup blueprint, add a variable of the type pickup type, give it the same name, and make it instance editable. Under the construction script, run a switch off of the pickup type enum. For the dot pickup, just go straight into the parent script, but for the power pickup, grab the static mesh and set world scale 3D to new scale 0.5, 0.5, 0.5. Now the pickup will change sizes depending on if it's a power pickup or a dot pickup. Next, we need to set a pickup radius with the sphere collision component. Attach it to the static mesh, reset the scale, and set the sphere radius to 100. On event begin overlap with the pickup radius, cast to base player character. Set a variable, and we'll come back to this so we can call some functions from this event. Switching back to our player character, let's hop on the event graph, and at event begin play, we'll need to get our player controller. Go ahead and set that to a player controller variable, since we'll need access to that later on. After this, we'll need to get all of the actors in the level of class base pickup. Set that array to a variable called allPickupsList, get the length of that list, and set our total pickups variable to that amount. Then we'll make a function called completionCheck. In this function, get the allPickupsList, remove index 0, then check to see if the new length is equal to or less than 0. Off the true, we'll later call an event to end the level. Now we'll make another function that we can call each time we pick up a pickup. Let's call it increaseCount with one input type, which is the pickup enum type. We'll get our picked up amount variable and increment its value when this function is called. Next, we'll play sound 2D with a 0.5 volume. The sound played will be selected by the pickup type. If it's dot pickup, play the dot collected sound. If it's power pickup, play the power pickup sound. And after that, call the completionCheck function. And now we're going back to our pickup actor. Off of the player variable, we're going to call the increaseCount function that we just made in the player blueprint. Plugging in our pickup type variable, run a switch off of the pickup type enum. Later we'll set up something for the ghost to be vulnerable when we pick up a power pickup. Then check to see if this actor is valid. If it is, destroy the actor. We're almost done with our pickup, but first we need an enemy so we can let the power pickup do something to the enemies. So we'll quickly make a child from our master character and this time call it base enemy. Firstly, we'll need to go to our class defaults and uncheck the variable can character die, since the ghost can't die until a power pickup is collected. On the event graph, first we'll want a variable for our player character, cast to base player character, and name the variable player character. We'll make three more variables, all of which are booleans. The first is called chasing player, set to true. Next is running from player, set to false. And third is called chase started, set to false. Squash and stretch the static mesh until it looks different from your player character. Then we'll need a capsule collision component parented to the static mesh called collision radius, and ensure it surrounds the static mesh entirely. You may need to shrink the inherited capsule component as well so that this works. On our component begin overlap with the collision radius, check to see if the other actor is equal to our player character. If it is, run a branch off of can character die to see if the enemy can currently die or not. That will determine what happens when the player touches the ghost. Off the true path, run character death function targeting self. If false, check to see if the player character can die, and off of that branch for true, call the character death function targeting the player. And you don't have to do this, but I thought it would be fun to have my character change color to the same color of the enemy that killed him. So I created a variable in my base player character of the type base enemy, and I set that variable here just before my player character calls the character death function, and I'll have the information of the specific enemy that killed me at the time of my character's death. Now we need to add the critical component of what the game should do when the level ends. Back in our base player character, create a custom event called level end. Immediately disable movement off the character movement component. We'll call the color change event from the master character. The color to change to will be selected from the boolean is character alive. If the character is alive, then they will shine bright white like a star in the night sky. If they're not alive, we'll do another select node off of the false value, grab our enemy variable, check to see if it's valid. In case we die from something that isn't an enemy, like falling off the map or something, we can have the false value be set to pure black. But if our enemy variable is valid, grab their color variable and plug it into true. Then we'll set a global time dilation, value 0.3, set a small delay, 0.2, check to see if our character is alive or not again, and later we will determine here as to which widget is going to be displayed. Now we can override our parent's character death event with event character death, set is character alive to false, set can character die to false since we're already dead at this point and don't want to run level end more than once if multiple enemies bump into us while we wait for the level end widgets to pop up. And then run level end and we'll play sound 2D, the sound will be hero's death. Next we're going to need a list of all the enemies in the level. We're going to do this exactly how we got our list for the pickups in the level. Get all actors of class base enemy, promote that to a variable called enemies list. Now we'll create a custom event for when a power pickup is collected. Call it collected power pickup. Get our enemies list and run a for each loop. From the array element, check to see if each enemy is alive. If they are, set running from player to true and can character die to true. Also run a color change to change their color to pure white so that there's a visual indicator of their vulnerability. When that loop completes, run a retriggerable delay, promote that to a variable called power pellet duration, and make that instance editable. Then run another for each loop from the enemies list again so we can reset the ghosts that weren't killed. Off of the array element, check to see if the ghost is alive with a branch. Off of the true path, set running from player and can character die to false. Set chasing player to true and run another color change back to their original color variable. Now back in our base pickup blueprint, off of the switch we made for the pickup type enum, we'll call the collected power pickup function from the player reference and reconnect it to the isValid check. And to finish off the base pickup, go ahead and select the static mesh, set collision to no collision. Now we are completely done with our pickups, and we now only need to set up some basic movement logic for our enemies and create some on-screen graphics. Let's finish up our enemy character. On event begin play, let's make some easy to adjust variables for our enemies. Off of character movement, set max walk speed and promote it to a variable called max walk speed. Ensure that it is instance editable. Next, run a get controller for the enemy pawn and set that to a variable since we'll need a reference to it later. After that, run a delay node. Set the input to a variable called chase delay and make it instance editable. After the delay finishes, set the chase started boolean to true. Now we can easily adjust our characters individually when they're in the level. Next, we'll have to set up what happens when our enemies die. Off of event character death from the master character, set is character alive to false, set running from player to false, and set is chasing player also to false. Then color change to a darker blue than what we set for the geometry in the level. Lastly, we'll set up the movement logic from event tick. Off of event tick, run a branch to see if the chase has started for the enemy. Off the true path, check to see if we're currently running from the player. Off of that true path, we'll set what the enemies do when they're running from us, which will be after we've collected a power pickup. We'll set up a do once node, run an AI move to node. The pawn input will be self and the destination will be get random reachable point in radius, with a radius of 10,000 in the player character's location as the origin. This should cause our AI to go kind of wild. Off of all of the inputs from the AI move to, run a delay with a random float range from 0.5 to 2.0. Then reroute all of that back to the do once node's reset input to reset it. If the enemy is not running from the player, we'll check to see if they are chasing the player. If they are, run a simple move to actor with the enemy controller as the controller and player character as the goal. If the enemy is not chasing the player character, then they're running back to their base, and we'll set the location of that base with an actor variable. So create a basic actor variable called home base and make it instance editable so we can select which actor in the level will represent the home base. Create a branch to see if the enemy's current location is equal to, with a variance of 100 units, the location of our home base actor. Off of the false path, run a simple move to actor, with enemy controller plugged into controller and home base plugged into goal. If the branch is true, run a delay. Set the amount to a variable called rest delay and make it instance editable. This will determine how long the dead ghosts stay at their base to rest. Once the delay is completed, set is character alive to true, can character die to false, and chasing player to true, and run a color change function to the enemy's original color variable. Now our enemies are completed, and we can easily change their parameters right inside of the viewport. Speaking of the viewport, don't forget to add a basic nav mesh to our level and ensure it encompasses our entire play space. That will allow our enemy AI to move. Our enemies are now completely functional. One of the last things we have to do is make our menus. So we have to create 4 widgets. One for the player's user interface, one for when the level's completed, one for when a game over happens, and one when you complete the game. But to make it easier on ourselves down the road, let's make a quick function to change our input mode in our base player character. So in our base player character, create one more function called setInputMode. We'll create our last enumeration called input mode with 2 enumerators. First one is called UI only, the second being called game only. In the function setInputMode, have one input called newInputMode and of the type input mode, and run a switch off of that enumerator input. For UI, grab our player controller variable, set input mode to UI only, and set show mouse cursor to true. And for game only, off of the player controller, set input mode to game only, and set show mouse cursor to false. Now, as long as we have a reference to our player character in our widgets, we'll be able to call this function easily. Let's set up our game over screen really quick by duplicating our main menu widget. Change the text to game over, duplicate the button. We'll need one to be retry the current level and the second to be return to main menu. Change the text accordingly, ensure both of the buttons are on screen and give them proper names. Switching over to the event graph, we'll need a reference to our player character instance. So create a variable of the type base player character, make it instance editable, and very important to also make it exposed on spawn. We'll be able to set the variable when the widget is created now since it is exposed on spawn. On retry button clicked, we'll play sound 2D, which will be the menu sound, off of our player variable, set input mode, game only, get current level name, and open level, plug in the string into the name. On main menu button clicked, simply play sound 2D, which will also be the menu sound, and open level main menu. Now we're done with the game over widget, and we'll start on the level completed widget. First, duplicate our game over widget, delete one of the buttons, center the remaining button, and change the 2 texts accordingly. We'll need to congratulate the player, and the button will bring them to the next level. On next level button clicked, play sound 2D, which will be the menu sound of course, off of the player variable, set input mode to game only, and open level. The name will come from the player variable called next level. Plug it right in. But remember, we'll have to set up the name on our character in the viewport later, and this will have to be done in each level. And that's it for the level completed widget. Next, we'll need the game completed widget. Duplicate the game over widget and change the 3 texts accordingly. One button will bring the player to the main menu, and the other will be quick credits. Go ahead and rename the buttons, and on main menu button clicked, play sound 2D, and open level main menu. On credits button clicked, play sound 2D, the menu sound, and print string a bunch of text on screen. It's not a real credits roll, but to be fair, barely anyone worked on this game. Lastly, we'll need to create our UI widget. Duplicate our level completed widget, delete all items in the hierarchy except for the canvas panel, add a horizontal box, put an image and 3 texts into the box. Leave the image blank, but center align it since it does already look like our blocks in the level, and change the first and last text to numbers, while the middle text will be a slash to divide the numbers. Go ahead and bind the first number to our player's picked up pickups variable. That's a mouthful. And the last number to the player character's total pickups variable. Delete all the code in the event graph and we are done with the widgets. Now let's go back to our player character to add the widgets on screen. In base player character, at event begins play, create the UI widget. Promote to a variable called HUD and add to viewport. In our set input mode function, ensure that the in widget focus is then set to the HUD. I'll make a sequence node to make this code look a little more neat in the event graph off of begin play. Finally, off of the level end custom event, after we check to see if our character is alive, create a widget for the false path. This widget will be the class game over widget. Plug in self for the input, add to viewport z order 9, set input mode to UI only from the function. Off of the true path, Run another branch to see if the next level variable is set to whatever name you want to use for our last level. I'm just going to use the number 0. This will check to see if this is our last level. Off of the false path, create a widget of the class level completed. Plug in the cell for player character, add to viewport zorder 9, and set input mode to UI. Off of the last true path, create a widget of the class game completed, add to viewport zorder 9, and set input mode to UI. We are done with our player character, but we need one last actor to act as our kill floor. But it's only going to take like 2 seconds. So let's create another basic actor called Death Plane. Add a box collision, set the box extent in X and Y to 10,000. On begin overlap for the box, cast a master character, and run the character death function. So anything that touches the box collision will die. And congratulations, we are done with all of the coding. So let's grab our skybox, set brightness to 0, set the sun height to -1, turn up the star brightness to double what it was, set all the colors to black except for the overall color, and set colors determined by sun position to false. Now we can place our character in the level. Remember in the details panel to set their color, next level, and power pellet duration. And it's also very important in the details panel under pawn, don't forget to set auto possess player to player 0. Now let's throw 3 enemies in the level, set each of their colors to something unique, set their chase delay, rest delay, max walk speed as well. For their home base, we'll need to place our music controls into their base location, and for each of them, set their home base to the music controls actor. Now they'll use the position of the music controls as their home base when they get killed. If you want a visual representation for your music controls actor, add a billboard component. At this point, we can litter the floor with the pickups spaced out 100 units each. Remember to change a few to the power pickups to give yourself a chance in the level. I'm going to organize my world outliner a bit with some folders. Don't forget to place a death plane in the level. I'm going to set mine at -900 in the Z direction, 00 for X and Y. And now we have an entire completed 3D Pac-Man level. For each additional level that you may want to create, simply duplicate your current level, change the name to the next number, remember to change the previous level's next level variable in your player character, and then you can customize your level geometry. You can add more enemies, change their speed to higher or lower. Just keep in mind that the AI doesn't do very well in super confined spaces, so give them some room to breathe, but the game can get really intense if you set their speeds to high. You can add more pickups, whatever you want to do. It's all up to you. Don't forget to adjust your music controls. You can change the pitch to higher or lower. And lastly, don't forget to add a quit game button on the main menu widget like I did at first. And for a bonus, I did add a super fast zip mode to my player character by creating a change max speed function. When shift is held, change max speed and jump Z velocity to high values, and when it's released, change them back to their default values. I even added a particle system to turn on and off when shift is held. It adds a lot more fun. I ended up making 3 levels that got progressively harder, probably too hard to be beaten. Remember that you can have my version of the completed project for free in the description box down below. Thank you so much for watching. I really appreciate you. Don't forget to leave a big thumbs up and a comment down below on what you may want to see in future videos. Hope you learned something on how to make a fully functional arcade-like video game. I'm here to help you think like a game developer, so stick around for more videos like this.